Energy flow and its importance. We know that all organisms get the energy which they need to survive by breaking down food molecules. Where do these food molecules come from? Autotrophs. Some living organisms are able to produce food molecules themselves by harnessing the energy in sunlight through photosynthesis. They use some of these food molecules to satisfy their own energy requirements. The other food molecules remain stored in their bodies. Such organisms are called autotrophs or self-feeders. Properties of autotrophs. 1. Autotrophs make their own food. 2. All green plants are autotrophs. 3. They are the producers of the living world. Heterotrophs. Organisms that can't make their own food and must feed on other organisms for energy and nutrients are called heterotrophs. They are the consumers of the living world. Consumers have the following levels. A. Primary consumers. Organisms that feed directly upon autotrophs are called primary or first-level consumers. They are commonly called as herbivores. Examples are grasshopper, seed-eating birds, elephants, and fruit bats, etc. B. Secondary consumers. Organisms that feed upon the primary consumers are called secondary or second-level consumers. They are commonly known as carnivores. For example, frogs, owls, foxes, etc. C. Apex carnivores. The final feeder that no one directly eats is called the top or apex carnivore. For example, tiger, leopard, and eagle, carnivores that consume by killing and eating herbivores or other carnivores, are called predators, and their food is described as their prey. D. Omnivores. Organisms that feed on both autotrophs and heterotrophs are commonly called omnivores. Human beings are a good example of omnivores. Another example of omnivores is bears. Detrivores. Some organisms feed upon dead bodies of autotrophic or heterotrophic organisms. They are called as detrivores or scavengers. For example, termites, crows, vultures, and pigs. The decaying remains of dead organisms are called detritus. Common detritus eaters include a number of worms, shellfish, mollusks, and crabs. Decomposers. The organisms that decompose or break down dead organisms and return the nutrients to the soil are called as decomposers. They are also known as saprophytes, for example, fungi and bacteria. Food chain and food web. Food chain is linkages of organisms within an ecosystem in which each link feeds on the one before it and is fed on by the one after it. Only the first link in the chain is a producer and all the rest are consumers. It rarely happens that an organism eats or is eaten by only one other kind of organism. So, food chains in nature are rarely simple. It is more commonly seen that an organism may feed on several different organisms and in turn be fed upon by several different organisms. For instance, an insect may eat the leaves of many kinds of plants, and it in return may be eaten by either a frog, a lizard, a bird, or a mammal. If this were to be represented as a diagram, we would get a complex branched web. Different food chains intertwine with one another and form the intricate networks called food webs. Energy pyramid. Each level in a food chain is called a trophic level or feeding level. Trophic levels are the feeding position in a food chain. All the producers in an ecosystem form the first trophic level. The herbivores form the second trophic level, and the first level carnivores form the third trophic level. You must understand that a given living organism does not necessarily occupy the same trophic level at all times. For example, when a snake eats a rabbit that has eaten grass, the snake is at the third trophic level. But when the snakes eat a frog that has eaten a grasshopper that has eaten the grass, the snake is at the fourth trophic level. Organisms at any trophic level do not pass on all the energy that have captured from the sun or the previous trophic level. Some energy is used up by them for carrying on their own activities such as breathing, growing, and moving. Some energy is lost as heat while it is being converted from one form to another inside the organism's body. It is only the energy left over after all these activities are carried out that is stored in the body tissues of the organisms and becomes available to the next trophic level. Energy leaving a trophic level is always much less than the energy that had entered it. That is why, if the total energy trapped from sunlight be a producer and the quantity of energy that gets passed on to each trophic level thereafter is diagrammatically represented, a pyramidal figure is formed. We call this figure an energy pyramid. It shows us at a glance how energy travels up a food chain. Most decomposers are fungi or bacteria. In the process of feeding, they use the energy left in dead matter and also cause the dead organic matter to break down into simple substances that easily mix with air, water, or soil. From here, they are consumed by plants and soon find themselves once again at the beginning of a food chain. Decomposers are crucial biotic factors in any ecosystem. If it were not for the decomposers, the nutrients that entered food chains would remain locked up forever in the waste thrown out by the bodies of the organisms and after their deaths in their bodies. Just imagine what would happen then. Less and less nutrients would remain available to plants, and through them to other creatures, the waste would go on building up around us till all life on earth would be overwhelmed by its own waste. The ultimate source of energy in an ecosystem is the sun. Part of the energy received by an ecosystem from the sun is stored in food molecules by plants. When this energy is transferred from one trophic level to another trophic level till it is used by decomposers. Finally, the energy is released in the form of heat. No energy in the ecosystem goes back to the sun. Thus, the flow of energy in an ecosystem is unidirectional. Do you know this? The following table shows time required for decomposition of different types of materials. Banana peel takes 3 to 4 weeks to decompose. Paper bag takes 1 month. Cloth takes 5 months. And woolen socks takes 1 year. Wood takes 10 to 15 years to decompose. Leather shoes take 40 to 50 years, while a zinc box may take 50 to 100 years, and an aluminium box takes 200 to 250 years to decompose. Did you know that the plastic bag takes 10 lakh years and a styrofoam or thermocol cup may never really decompose at all? Cycle of nutrients in terrestrial and aquatic ecosystem. Though the flow of energy is unidirectional, the flow of nutrients in an ecosystem is cyclic. All the organisms require nutrients for their growth. Plants require water, carbon dioxide, and elements like phosphorus, potassium, nitrogen, etc. Animals need proteins, amino acids, vitamins, and elements. Plants absorb different nutrients from air, water, and soil. These nutrients are transferred from one trophic level to another trophic level, and so on. Finally, the decomposers decompose the dead organisms, and the wastes of living organisms return these nutrients back to air, water, and soil, which in turn are absorbed by the plants. Thus, the flow of nutrients in an ecosystem is cyclic. The path through which a nutrient travels as it moves from the air, water, or soil into the bodies of living organisms and back to the air, water, and soil is called a biogeochemical cycle. The biogeochemical cycles of some common elements like carbon, nitrogen, and phosphorus are studied and mapped in depth by the scientists. Nature's mechanisms in maintaining balance. Two main characteristics of an ecosystem are 1. Unidirectional flow of energy, 2. Cyclic flow of nutrients. Every ecosystem performs both these jobs. The health of an ecosystem is judged by efficiency in doing these jobs. Every ecosystem is unique due to presence of various significant organisms. It has a specific system of managing flow of energy and nutrients. The more the ecosystem diversity, more will be its capacity to keep energy and nutrients flowing.